Welcome to Training Tuesday, everybody. So glad you could join us today. I am Heidi Reese here at Dayton Superior, and I am the Training Programs Manager. Just a couple of things to talk about before we get going on the training. Everyone who has joined is joined muted, but I still want you to ask some questions. You can do that throughout the presentation. Definitely at the end, we'll have a mini question and answer session. So how do you ask questions? There is a Q&A or the chat functionality in Zoom. Go ahead and use either of those and we'll get those addressed for you. At the end of the presentation specifically, if we don't have time, we always make sure that we give you an email and we'll get those answers to you. As a reminder, each of these webinars are recorded and placed on DaytonSuperior.com's YouTube channel. And then we also put them on DaytonSuperior.com. Just search on Training Tuesday or for Training Tuesday, and you can get to the link where you have the top 4 that we've done, along with any of the other ones that we've done in the past. And I think we're on number 98 today, 99 maybe. Yeah, that's crazy. So you heard Chuck's voice. He's going to be the one who is chatting with us today. But before that, I want to tell you that this presentation is intended for training purposes only. We're going to go through some stuff, but if you're going to refer or use it in the future, please look to DaytonSuperior.com to get technical specifications for any of the products that we're going to talk about in here. There's technical data sheets, safety data sheets, applications, you name it. And at the end, we'll talk about the resources as well, so you know what you have and that we can provide to you. So who is Dayton Superior? We're not just about the accessories that we're going to talk about today, but we are the leading provider of engineered solutions for, you named it, the concrete construction industry. We do specialize in accessories, as you probably know, chemicals and forming as well. But in addition, we provide you with engineering services so we can help you with just that, engineering. We have links on DaytonSuperior.com that can provide you with precast or tilt-up, bridge deck, anything that you might need. We have an on-site group of engineers that can assist. In addition, we stand behind our products for the training aspect. We do these Training Tuesdays on different topics every Tuesday at 1 p.m. Eastern. But if you need something more than just the half hour that we're going to do today, please contact us at training@DaytonSuperior.com, and we can talk to you about our needs, your needs, I should say, and set up a customized training just for you. Okay, so Chuck giggled, so we know it's him. He's going to be going over light forming construction today. Chuck is our national training manager. He has been hanging out in the construction industry, more than hanging out, for over 49 years and about to make it his 50th in a couple months. The first 20 years of his career, he was in sales and was a dealer for accessories and forming, and as well as chemicals. And he has a business and civil engineering degree and is definitely Dayton Superior and Simon's subject matter expert. So let's get started with light forming constructions, AKA sticks and boards.
Alrighty. Thank you, Heidi. And good afternoon to everybody. So as Heidi alluded, we are going to talk today about light forming, primarily sticks and boards. We will be talking about, what are we talking about for the form work? Well, concrete, when it's delivered to the job site, is typically in a plastic state, meaning it is flowable. Typically concrete in about a 70-degree day, it's going to take roughly an hour to take initial set. So typically you're going to look at concrete when it comes to you in a fluid state, means it does just that. It flows wherever you want it to go. And then it can be molded to any shape. Well, think about your forms as being that mold that's going to hold the concrete in its shape. So here it is. You got your forms in place. The concrete gets placed. Once it gets hardened, typically, like I said, in about an hour, concrete will start setting up. So that's an hour from the time it is placed, not the time that you fill it all the way up, but the hour that you place when you place it. And for your concrete, you have to look at, the big problem is we have to make sure we take into consideration concrete form pressure. This is because concrete typically weighs about 150 pounds per cubic foot. Okay, so what that does is it will exert a pressure in all directions of 150 pounds per square foot. So what that means is for every foot of concrete that you put in your form, you're going to be putting 150 pounds of pressure pushing outward in each direction. This gets manipulated or actually multiplied as you increase the amount of feet of concrete that are poured on top of each other. One thing you don't have to worry about is regardless of the width of the form, is the pressure remains the same. So, and this is one of the problems, I shouldn't say problem, but it's probably one of the most asked questions that we have. I have a 48-inch thick wall. How come I don't have more pressure pushing outward? Well, it's because the concrete height is only pushing outward when you only have 1 foot of concrete, it's still only pushing what the value of 1 foot of concrete outward. 24-inch, same thing. 1 foot of concrete will only resort 150. Now, where does this become a problem? When you pour taller walls, you can see how the concrete actually has multiplied exponentially down through by every foot of concrete. It's added 150 pounds of pressure pushing out. This is the same if the wall is 12 inches, 24, 48, or let's go the other way. Let's say it's only 6 or 8 inches thick. The concrete will be pouring a lot out of the truck, filling that void will be coming out of the truck probably at the same rate that you normally would pour, thus increasing the amount of concrete or the full liquid head in the concrete form, creating more pressure on a smaller wall. So typically, thinner walls are usually more of a problem to pour because you have to control the concrete pour rate. So as the concrete starts to cure, remember I said 1 hour at 70 degrees. After an hour, that first foot of concrete typically is going to be cured. It's no longer going to be exerting the pressure. It's still not going to be fully set, but it will be set enough so that it has released the pressure pushing outward on the form. So it's become self-supportive at that moment. So every hour goes by. So typically, if you figure you pour every 4 foot an hour, 4 foot of concrete in an hour, 15 minutes per foot. The first foot, once you start at the hour and 15 minutes from the time you start, that first foot, an hour and 15 minutes will be set. An hour and 30 minutes, the second foot will be set. Hour and 45 minutes, etc. So you have to look at concrete at that fashion. You have to be very careful with temperatures. This time of the year, especially for the northern half of it, I say the northern half of the country, but it seems that the southern half of the country has been hit with cold temperatures, etc. now too, this time of the year. Pay close attention to the air temperature. 70 degrees is typically going to be an hour. If you're at 40 degrees, it's almost 2 hours. If you're at 90 degrees, it's going to be like 40 minutes. So it will be quicker. So you have to take into consideration the warmer the temperature, the faster the set, the colder the temperature, the slower the set. If you pour a concrete wall at 5 foot an hour, typically you're going to put 750 pounds per square foot on the form. So 5 foot per hour. So at the end of the 1 hour, you're still going to have that 750 down at the bottom. Hour and 18 minutes, that 750 will go away. But if you only pour 3 foot an hour, you're only going to put 450 pounds of pressure on your form. Thus, looking at what your concrete form will actually withhold is what you have to look as a system. So what your form will hold is designed how fast you can pour your concrete. In our handbook, we actually have a plastic chart. We have a chart here for plastic concrete rate of pour. It's in the concrete forming accessory handbook, the front pages of the book. So typically what you're looking at is, if you're looking at plywood forms, which are typically what we're going to talk about today. You're going to pour roughly 4 foot an hour with that, because typical plywood, you typically don't want to exceed 600 pounds per square foot with standard plywood. Why? Because it will begin to pillow on you. And it's not designed to actually withstand the pressure until you start adding layer upon layer of additional reinforcement of plywood, or excuse me, not plywood, but 2x4s on the backside for shoring the purposes. So we talked a little bit here about the wider forms. You don't have to worry about those so much. Every form that we send out here, every tie that actually goes out of here, comes from Dayton Superior, actually has a factor of safety of 2 to 1. And what that 2 to 1 typically relates to the product's ultimate strength divided by the strength, safe working load that's required by ACI. ACI has typically told us that we have to have a 2 to 1 safety factor on all concrete forms. So, including all ties. So ties typically come out at a 2 to 1 safe working load. So that means if you have a standard tie, 2,250 pound snap tie, that's a light duty standard snap tie, means that its ultimate strength is roughly 4,500 pounds. Okay, so those two products here, you typically are only going to see every tie that comes out of Dayton Superior and every other form tie manufacturer has to list their tie with a safe working load. So those are standards within the industry. So let's talk about what we're going to talk about today. Sticks and boards. Typically the most common forming system in the marketplace today still. You're looking at plywood and 2x4s, 2x6s. Primarily in today's marketplace, most contractors are going with standard 3/4 to 5/8 inch plywood and 2x4s. What they typically do is they will form up a wall section, look something pretty similar to this.
Does it have all the arrows and the words on there?
Huh?
When they form it up, does it have all the arrows and the words?
No, the arrows and the words aren't there, and there's no pointing at this or that.
Oh, that's too bad.
What we have though is we've got a couple of different types of ties. We have a washer snap tie and a cone snap tie. Now, both of these ties were originated back in the
70s.
1919.
Oh, wow, that's a long time.
So, and they haven't really changed a whole heck of a lot. So you're talking about a product that has been around for a little over about 105 years right now. And really the only thing that has been upgraded is where the anti-spin is and the head of the tie itself for breakback. But the tie itself has pretty much been that, was actually designed and it's still that commonplace in the marketplace. It still probably holds probably a 55% market share. So, and that is whether it's a tie that has the washers or it has the plastic cones. Now, the cones are typically used when the contractor has issues, he wants to make sure the break back occurs. Or it could be an architectural feature. So you need to check your specifications component within concrete forming. This forming is the responsibility of the contractor, but they may require an architectural feature that they want the cones for where the ties are located. So that is usually specified out. Otherwise, it is a preferential thing on within the contractor's rights to actually pick. And what it is that the tie will actually be developed to go through a single sheet of plywood plus either a stud and a wailer, or a stud and, or excuse me, a wailer and a strong back. Or it could just be plywood and a wailer. So there's a couple different variations here. Those would be require short end and long end, and we'll elaborate on that here. Typically, most concrete formwork is set up on a silt plate, which is actually anchored to the footer, and that's what the forms get set on. And when I said we were going to be building with wailers and strong backs, all this material that we've been talking about, plywood sheeting, wailers and strong backs, they're called load gathering members. What it is, those systems actually are used to collect all of the pressure that the concrete is pushing out and transfer it to the tie. So basically, if you can think of it as a large funnel of system, your forms come in, they take the concrete pressure flow, the flow hits the sheeting to the stud or the wailer to the strong back or wailer, depending on terminology, and then it transfers all the load to the tie. So here you'll have the two different forming systems. Now, realistically, contractor preference on this also is whether they use a stud and a wale, which is on the left side. On the right side is a wailer strong back system terminology. A lot of it has to do with the direction, strength direction of the plywood, how it is laid, if it's laid down or standing up. So typically, if your plywood is standing up, you are seeing a stud with a wale, and when you lay the plywood down, you're putting a wailer and then a stud, strong back behind it. But once again, both systems do the same exact thing, so a lot of it is contractor preference. For those of you that are familiar with Dayton Superior, and those of you that, if you're not familiar, we have an A4 Sure Snap hex head tie. Typically, it's designed so it has a hex head on the end of the tie to help make it easier to break back. What it entails is you grab it, and typically the old way you used to have is you grab a hold of the tie with like a pipe wrench or something like that, it's a set of pliers, and twist the tie. Well, that sometimes would, your tie would, your wrench would slip and everything else, and guys would muck up their hands and knuckles and everything. Well, with this system here, you can now attach an impact wrench to the end of the tie and spin it backwards or forwards, depending, and that will snap the tie back, because each tie is developed with made with the break back. Now, the break back is basically from the surface of the concrete to the inside part of the concrete, where you want the product to break back. This is primarily to give you concrete coverage within your system. The bottom was how the system is set up with a John A bracket down at the bottom. Because that system right there, the John system, everything that's associated with the John system is developed around a 2,250 pound tie, which is the standard duty tie. Now, we also have a heavy duty tie, which is 3,350 pounds safe working load. And both of these ties have a 2-to-1 safety factor. When you're looking at all the tie systems that are out there, especially in the snap ties, you've got a couple of different variations and options. The first option would be the middle section is a tie wedge being used, and that can be used on a single waggler system or a stud and a waggler, stud and strong back system. Uses a standard duty tie with what we call a hairpin or a omni wedge. You may have a few other names for it around the country, but I'm not going to elaborate. So, and in the center of the top of the page here, we have our John system. We have our A bracket and C bracket, and we'll talk about them in a second. The A bracket is typically designed for a single waggler system. The John C bracket is typically used where you would have a strong back, or if you use a strong back and a waggler. The system on the right-hand side, excuse me, on the left-hand side of the page, that is our Sherlock system. This system here is extremely popular in certain areas. Contractors that own this hardware swear by it, and they've had great success with this product over the years. It's a great little loop tie situation. So the tie, it works also with a 2,250 pound loop tie, a 1-inch break back, etc. So when we're talking about determining the lumber dimensions, I said always you're going to have your 3/4 inch plywood. That's the standard. Whether you have a stud or a waggler next to the plywood, it's just a terminology term. That's a 3.5 inch. If you have a member behind it, whether it be a waggler or a strong back, that's another 3.5 inches. Then you have to have a 1/2 inch for your wedge, take up for your wedge, thus giving you an 8.25. Now, if you have only a waggler system, which typically would be something similar to a John system, but we're not going to use the John system. Well, we could use the John system, John A bracket. You only have the plywood and a single 2x4, and then the end of the tie. So basically, you're going to have a 3/4 inch plywood, 3.5 inch 2x4, and 1/2 inch take up, giving you the 4 3/4 end. The Omni wedge typically was developed to actually make the take up for the tie, so it actually helps for any inconsistencies in lumber dimensioning, and also for helping make everything rigid with the tie, keeping it snug within the forming system. John forming system typically is probably the fastest single waggler system in the marketplace to actually connect everything to. Use a snap tie, tie wedges, or John clamps. So here you can see a single waggler system basically uses plywood with a single waggler. And that waggler is held into place with a John A bracket. Typically has a 5/8 inch eccentric that takes up just like your tie wedge, but your eccentric already is your tie wedge. It's already attached to your bracket, and you can actually attach your 2x4 in place. The C bracket is typically used where you're going to have to attach strong backs or a double waggler system that basically slides over the snap tie end, just like this, your John A bracket would. And what this does is actually cups both of the 2x4s that you would actually have sitting side by side to actually hold it in place. Now remember, these are only used, John's system is only designed for a 2,250 pound usage. Go to a heavier duty tie, you run the risk of actually fracturing the A bracket or the C bracket. So how to use the John bracket, and this is all pretty much all forming systems using snap tie systems. Guys will stack drill their plywood. Typically take using the 5/8 inch drill, stack drill your plywood so that you can basically have all the holes pre-drilled within your formwork. Place it in, put it in place. Put your tie through, attach your John A bracket on the backside. And then every 8 foot or so, you're gonna attach a strong back. So one every fourth row, typically you're going to have a tie that's gonna go from a short end to a long end. You've also got nailer plates for adjustability. These are basically for plumbing the forms. Typically, if you have a bent plate, the one on the left here, that one is designed specifically for wood forming. So you can actually attach any whaler systems. You can basically attach the whaler. It makes it a little bit easier because the plate is bent at a 45-degree angle. And the flat plate typically can be used to attach to strong backs or to modular forming systems. The Sherlock system, as we talked about, is a similar system, 2,250 pounds. It has a 1 inch by 1 inch self-centering cone, which basically centers on the hole so you don't get any leakage. The cone itself enables you to have that loop coming through the tie that actually will be connected with the Sherlock bracket. And the Sherlock bracket is typically used as to wedge the 2x4 against the plywood face and tighten it up against the formwork. So it uses a pressure fitting. The one nice thing about this system is you don't have to use a longer end tie with the system. If you have to put a strong back in place, we have what we call the Sherlock bracket, which basically attaches right to the 2 ears on the Sherlock bracket that are sitting out there. What you are looking at is these 2 openings right here and here is where this is going to go, right in there. So those pieces are going to just snap over the top of it. You slide your 2x4 in between and then pull the handle down to snug it all up tight. Then we also have our spreader cleat system. For those guys out on the West Coast where they don't typically have foundations, basements, et cetera, most of the slabs on grade, a lot of times what they'll do is they will just pour a little knee wall for the foundation for to set your sill on and build up from. These are spreader cleats that basically are preset for the wall thickness and the lumber dimensions. No ties required. Put one on the bottom, one on the top. The only thing that's left in the concrete is the one on the bottom. You then take the one off the top and on the next job, use that one that's on the bottom. We've also got pencil rod for those guys that find themselves in the situation where they have issues. Pencil rod is a great product. It's just basically a 1/4 inch rod wire basically sticking out through there. You use the clamp, a D12, D12F, or D12S to clamp to it. And you have a tightening wrench that coincides with it. This system is good for about right around somewhere in the neighborhood of about 1,100–1,200 pounds per tie. To make everything easier, we actually have a cross-reference chart, basically a selection system here. You can run through seeing what your system is, where you've got it, what strength you require, and what products you can use. Now, just as an alternate product here, we do have coil and ferrule inserts. Coil inserts, along with coil ties, can also be used in light duty to medium duty forming. Those systems are all available and they'll actually be included in one of our other training Tuesdays coming up here, probably in the next couple months or so. And you'll see what we have for use with the coils and coil ties. Most of the coil products all use coil thread, a DR rod or a Euro rod, which is European rod, which is a higher, fewer threads per inch than coil rod. So basically it threads together a whole lot faster. And you see that used in a lot of light forming and including medium to heavy duty forming. So resources. Well, you can use any of the search functions, so any of the products that we have on shown today, or actually any product within the Dayton Superior line, to come up to product pages, which will actually give you tech data sheets and handbook information as to what handbook they can find it. You can also download those pages if need be, because they are in PDF format, so you can actually download those. And everything here that we talked about is in our forming accessory handbook. You see TDS is similar to this. This is just the John A bracket that we talked about earlier. Typically, they're designed for 2,250 pounds and for a short end snap tie. One of the great things about DaytonSuperior.com is if you know where you're sitting or where your job's located, you need to get a hold of a salesperson, click on our apps. This will actually go to contact us. Maps will come up. You can select Dayton Superior or assignments representative, and it will give you the customer, the reps that are in that area and for what territory those reps actually cover. So those are all relatively easy to get to and for your use. And for training, as Heidi alluded earlier, if you do have a question and this isn't quite enough of what you need a little more information and would like more, feel free to contact us at training@DaytonSuperior.com. You can reach out to DaytonSuperior.com to get to the training Tuesday to see any of the presentations that we have done for Training Tuesday.
That's right, Chuck. And this month, we've got some special deals on a lot of what we talked about. So our Superior Deal of the Month is on special pricing on forming accessories that you see on the screen right now. We talked about the Sherlock and the John A and C bracket. And there's actually extras that we haven't talked about here. So just contact your sales representative for details. We showed you how to get in touch with them earlier on DaytonSuperior.com. So with that, if there are any questions, please feel free to put them into the chat or the question and answer, and we'll see what we've got. Thank you, Don. That was a nice comment. Is there any other questions? Okay, so we don't actually email the PowerPoint presentations out, but we do put them out on YouTube. So this exact presentation is recorded and you can see them out there just like you just saw now. And I will send an email to you letting you know when that's available. All right, so we're just a smidgen over time. If there is any other questions that you may have, Chuck and I are always here. Chuck mainly is the smarter one for the, the products. I do a lot of the organization and the PowerPoints, but just contact us at training@DaytonSuperior.com and we'll be happy to help. You got it. And so I was reading all the comments. I will send that email out for the YouTube. And I want all of you on the line, thank you for coming. And please have a fantastic Tuesday. And sign up for next week. We're going to be talking about splicing and some specification changes that are exciting. And you can check it out next Tuesday. See you then. Bye, everyone.
Have a good day.